This is Mr. Gillum, and today we're going to do a little review on mixed numbers and improper fractions. So by the end of this video, hopefully you can convert between mixed numbers and turn them into improper fractions, or you can change improper fractions into mixed numbers. So let's start by just reminding ourselves what a mixed number is. A mixed number is a combination including a number of wholes and then a fraction of the next whole. So for example, I could have 1 and 1/2. Or I could have 2 and 3/4. I could have 3 and 4/5. And these are just made up examples, but they're all examples of mixed numbers. And so a mixed number has the number of wholes, 1, and the amount of the next whole, 1/2. The amount of wholes, 2, and the amount of the next whole, 3/4 of the next whole. 3 wholes and 4/5 of the next whole. Okay? An improper fraction would be whenever the numerator or the top of the fraction is greater than the denominator or bigger than the bottom of the fraction. So for example, if I had 7 on the top, an improper fraction would be if there was a 6 on the bottom, because 6 is less than 7. Or 7/5 would be an improper fraction, 7/4, 7/3, or 7/2. I would not write 7 over 1 as an improper fraction because 7 divided by 1 is actually 7. So that would not be an improper fraction. That would actually be the whole number 7. But an improper fraction would be when the top number is bigger than the bottom number. We call that an improper fraction. So as you can see on every example here, the top number is bigger than the bottom number. Okay, and I didn't have to choose 7. I could have chosen 9/4. That would be an improper fraction as well. Anytime the top number, the numerator, is bigger than the bottom number, the denominator. Okay, and so what we're going to do is we're actually going to go right down to the very fundamentals of mixed numbers today, and we're going to change them to improper fractions. And so what I'm going to do is I'm going to sketch on my whiteboard here the amount of wholes and the amount of the next whole. So in this case, 1 and 5/6 is saying 1 whole and 5/6 of the next whole. And so the trick is going to be for Mr. Gillum to divide this evenly into sixths here. All right. So if I had this diagram, this example here, and I had 1 whole, okay, that means that all of the first circle would be shaded. Okay, 1 whole. If I have 5/6 of the next whole, as you can see, I've already divided my circle into 6. I would have 5 of them. Well, to be an improper fraction, I would need to know how many total sixths I have. And so an improper fraction, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 sixths would be the same as 1 and 5/6 because I have 11 1/6 pieces, or we would write that as 11 sixths. Okay, let's take a look at the next example here, and I chose a big number, 5, so I'm going to draw 5 wholes and 1/4 of the next. So because my last fraction is in fourths, I'm going to just divide all of these into fourths. Okay, just divide each of these into fourths, and it is a sketch. We're going to assume that each of these sections of each circle is an actual fourth. And so I have 5 wholes, so I want all of them in 5. Okay, there's 2 wholes, 3 wholes, 4 wholes, 5 wholes. And I also want one of the 4 pieces of the next whole. So to change that into an improper fraction, I just need to know how many total 1/4 pieces there are. So I have 1/4, 2/4, 3/4, 4, 5, 6, 7, 8/4, 9, 10, 11, 12/4, 13, 14, 15, 16/4, 17 fourth pieces, 18 fourth pieces, 19, 20 1/4 pieces, 21 1/4 pieces. So I have 21 fourths. That would be the improper fraction version of the number 5 and 1/4, or the mixed number 5 and 1/4, 21 fourths. And we're illustrating that through this diagram here. It's going to be important soon. Let's take a look at another one here, and this one says 2 3/10. And to write that as an improper fraction, let's just visualize it first. So I need 2 wholes and 3/10 of the next whole. So I'm going to divide each of these into 10 pieces. See if I can do that here. There's 8 pieces, and then 9, 10 pieces. And we're going to assume that they're all exactly 1/10. Okay, there should be 10 slices to each of those diagrams there. And so what I'm going to do is I'm going to actually fill in the first 2 all the way. Then we have 2 holes. So and then the next one, I only want 3 of the 10 pieces, 3/10 of it. And so to know what the improper fraction is to this mixed number, I would just count how many 1/10 pieces I actually have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1/10 pieces there. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 1/10 pieces there. 21 1/10, 22 1/10, and 23 1/10. So I have 23 1/10 pieces. That would be written as 23/10. Okay. Let's take a look at one more, and we're going to do one more diagram here. And this time we have 4 1/8. So I need 4 holes and 1/8 of the next hole. And because it's 1/8, I'm just going to top them all into eighths. All right, and I'm actually going to fill in the first 4 all the way because I have 4 holes. And then my last part, I just have 1/8, so I just have 1 of the 8 pieces. So to change this to an improper fraction, I need to know how many total 1/8 pieces I have. And so probably you're like, Mr. Gillum, you don't have to count by ones. I said, well, you know, we're just learning this. So 1, 2, 3, 4, 5, 6, 7, 8. And I know that each of these has 8 pieces, so really I have 8, 16, 24, 32. And then on top of 32 1/8 pieces, I have another 1/8 piece. That makes 33 1/8 pieces. Ooh, Mr. Gillum, I like how you did that. Looky here, guys. I have 4 holes. So in eighths, that would be 32 eighths. And then another 1/8. Over here, I have 2 holes, but there's 10, 20. 2 times 10 would be 20, and then 3 extra. There's 23. And 1 5/6, I have 6 pieces here, and then I'm going to add 5 to that. 1, 2, 3, 4, 5. There's 11. And then again, 5 1/4, I have 4, 8, 12, 16, 20. Plus 1 would be 21/4. And that's actually going to be our little shortcut way, if you find the pattern there, on how to find our mixed numbers, changing them into improper fractions. There's a pattern here. If I multiply 6 times 1, plus 5, that makes 11, 11/6. If I take 4 times 5 plus 1, that's 21, 21/4. And so there's a pattern. And so on your notes there, you have some fill in the blanks. Make sure you're writing these in. They'll make a little more sense as we do some examples. Step 1 is just multiply the denominator by the whole number. So step 1, 6 times 1. So step 1, 6 times 1. That's 6. Okay, step 2, add the numerator to the product. So this is the product. I'm going to add the numerator. Step 2, 6 plus 5. That equals 11. Step 3, the sum represents the numerator. The denominator is the same number as the original fraction. So I just need to know about that 6. So step 3, the sum is the numerator. The original denominator stays the same, 11/6. And you can see again that we have done this problem. We know that it should be 11/6. So that's awesome. There's a little arithmetic shortcut here. Let's do the next one. And again, step 1, I'm going to multiply 4 times 5. That makes 20. Step 2, I'm going to add 20 plus 1. Just add the numerator to the product. Okay, that equals 21. Step 3 just says 21 is the numerator and 4 is the denominator. The original denominator stays the same. All right, again, we'll go to the next one here and do another example. Step 1 says 10 times 2, that's 20. Step 2 says add the 3 onto that 20, that makes 23. And then step 3 says 23 represents the numerator and 10 is our original denominator. Right there, that's where that 10 came from. And finally, we'll do one more. Step 1 says we're going to take 8 times 4, that makes 32. Step 2 says we're going to add 32 plus 1, making 33. And step 3 says that's our numerator, 33. We need our original denominator, 8. So there's 33 1/8 pieces. All right. And now we're just going back to the improper fractions. We're changing those to mixed numbers. And really, that's a little simpler. You just need to determine how many times the denominator fit into the numerator. And so I wrote that in kind of a long way there. One thing I do want to keep in mind throughout as we're learning about fractions again is that a fraction bar means the same thing as a division sign. Okay, that's very important. That when you see a fraction bar, you think of the operation division. So what we're going to do is we literally are just going to divide the top number by the bottom number and see how many times the bottom number fits into the top number. Whatever the remainder is the numerator of our next whole number. So fill in those blanks, and I think they'll make a little more sense as we do an example here. Okay, so what I'm thinking is how many times this fraction bar here, that means division. Okay, it means the same thing. In fact, the division, actually each of these dots represents a number, and this fraction bar literally is in the division sign itself. So this means to divide. So when I think of 33 divided by 7, I know unfortunately 33 does not go evenly into, 7 does not go evenly into 33. So I think, okay, 17, 21, 28, 35. Okay, 35 is too far, right? So I know it goes in 1, 2, 3, 4 times evenly. And then it doesn't quite fit in a 5th time. Okay, so I'm just going to think, how much is there left over between 28 and 33? 29, 30, 31, 32, 33. There's 5. The remainder of 5. And that's 5 of the 1/7 pieces. Okay, 5 of the next 7 would fit in. Okay, not all the next 7 would fit in because that would be 35, but 5 of the next 7 would fit in. So that's the next part of the whole. 15/4. Okay, again, and you don't need to show this work on your homework. I wanted you to have it on your notes, but not in your homework. I'm dividing 15 by 4, and so I know 4, 8, 12, 16. Okay, 16 is too far. So I know it goes in 3 times evenly. That gets me to 12. So there's 12, 13, 14, 15. There's 3 left over. 3 of the next whole would fit in. 3 out of the next 4 would fit in. But not all 4 would fit in, because then we'd be at 16, and we only want to be at 15. 18/5. Okay, 5, 10, 15, 20. Okay, 20 is too far, so I know it fits in 3 times. And not all of the next 5 will fit in, because that would be 20. Only 3 of the next 5 would fit in. 16, 17, 18. Okay, again, 27/10. 10, 20, 30. Okay, 30 is too far, so I know 2 holes fit in. And then I know that if I'm just going to 27, going from 20 to 27, that's 7 of the next 10 will fit in. Okay, so from 20 to 27, that fits 7 more of the 10. Okay, sometimes you'll get an improper fraction that actually works out evenly. 2, 4, 6, 8, 10. It goes in 5 times evenly. Okay, so in this case there's no remainder. I don't need to write an improper fraction, or I don't need to write the last part of my mixed number. There's no fraction after the whole number. Okay, and again that happened in 15/3. 3, 6, 9, 12, 15. Oh look, that fits in evenly 5 times. So instead of writing the fraction, improper fraction 15/3, the better answer would be just 5. Okay, and so for improper fractions to mixed numbers, it's really just a division with the remainder as your next part of a whole. Okay, so that's it for today.